Hello students, today I'll be teaching a topic from module 2 and that topic is known as two-dimensional geometric transformation. Okay, under this topic you have this first topic and that first topic is known as basic two-dimensional geometric transformation. Okay, so we all know that what is two-dimensional. Two-dimensional is the one which will have only two axes. This is x-axis and this is y-axis. So any that is having two axes is known as two-dimensional, and the object that is placed in this two-dimensional is known as two-dimensional object. Okay, now two-dimensional, we know what is meant by transformations. Okay, transformations means what all transformation you can perform on a 2D object. Okay, for example, if you want, you can move this object from one point to another point. Okay, moving. Otherwise, if you want, you can rotate it, rotate at this angle or rotate at this angle, some angle, 90 degrees, 80 degrees, 180 degrees, you can rotate. Or you can either increase the size of an object or you can decrease the size of an object. So some transformations or some operations you are performing on an object, that is known as transformations. So let us see what all transformations are there. So the basic transformations we can apply on a 2D object are. So what are they? First one is translation, second is rotation, third one is scaling. Okay, so what is translation? We'll see what is translation. Translation means this is a point. Okay, you're just moving from this point to this point. That means you're changing this coordinate position to this coordinate position. That means you're moving from this position to this, and this is known as translation. Changing one coordinate position to another coordinate position. Second thing is known as rotation. Now what is rotation? You have an object here. You rotate it to 90 degrees, rotate it to 45 degrees or 180 degrees, rotate it clockwise or rotate it as anti-clockwise. Anything you do with an object, that is known as rotation. Okay. Third thing is scaling. Now what is scaling? You have an object here. Okay, this object you either increase it or you either decrease it. So scaling is nothing but increasing and decreasing of an object, size of an object. So how many transformations are there? 3. Which are they? Translation, rotation and scaling. So I'll come once again. Translation means one point to another point, you are changing the position. Rotation means you are rotating the object with some angle, theta, you can see. Scaling means you are increasing the size of an object or you are decreasing the size of an object. So let us see what is translation. Okay. So this is two-dimensional translation. Okay. So I have written the definition. What is two-dimensional translation? Moving a point from one coordinate position to another coordinate position is known as translation, as we saw at the last topic. Okay, so moving a point from one coordinate position to another coordinate position. Now you can see I have drawn a diagram here, and this diagram is having two axes, which are the x and y. Okay, you have a position here. Okay, given position, and this I'll call it as P. This point is there and this point is x comma y. I want to move this point to this point. That is, I want to move it from this position to this position, old position to new position. This new position I'll call it as P dash, and P dash is having x dash comma y dash. Okay, so x and y will be given. How to find out x dash y dash? Okay, so for this point to go to this point, this much of x you have to move. That means this distance you have to travel. From this much of x you have to travel to go to this point. And from this point to go to this point, this much y you have to travel. Okay. So what is this? Tx is nothing but distance across x. And what is ty? Ty is distance across y. So to move to this position, you have to move this of tx and this of ty. So what is tx? Tx is distance across x And what is ty? Ty is distance across y. So this pair tx comma ty is also known as translation vector or shift vector. Okay, so how to find x dash y dash? Given t p x comma y, tx will be given, ty will be given. Getting this 3, you have to find out p dash. Okay, so we have to find p dash, that is p dash x dash y dash, where tx comma y, tx and ty will be given. That means the point and the distance across x, the distance across y will be given. So what is the formula for finding x dash y dash? X dash is nothing but x plus tx, that is the old given point and the distance to move across x. X plus tx will give me x dash. And what is y dash? Y dash is nothing but y plus ty. So these coordinate points are given, you have to find out x dash and y dash. The same thing I will write it in matrix form. Okay, so what is p dash? Matrix form means write it in terms of rows and columns. Now what is p dash? P dash is nothing but x dash y dash. What is p? P is xy. What is t? T is tx and ty. Okay, so how to convert this equation into matrix form? Okay, so x dash y dash, I'll write it like this. Okay, and this tx ty, I'll write it here, and xy. So what is x dash? X dash is nothing but tx plus x. And what is y dash? Y dash is ty plus y. So in general, I will write this as p dash. P dash is nothing but x dash y dash. And this tx ty in general, I'll write it as t. And this xy, I'll write it as p. So what is p dash? P dash is nothing but t plus p, where p is the old coordinate position, p dash is the new coordinate position, and t is the vector, translation vector, which is tx and ty. Okay, so hope you all have understood what is two-dimensional translation. Okay, so I'll be solving a problem on this. I've done a problem on this. Okay, so what is the problem given here? Consider polygon with 3 points. Okay, and what is those 3 points? A 2 5, B 7 10, C 10 22. They have given a polygon and with distance across x and y as 2. That means tx and ty both they have given it as 2. So what I have done here is I have already drawn the polygon. Okay, put some points along x, put some points along y. Okay, so what is A? A is 2 5, draw a point here. What is B? B is 7 10, 7 10, put a point here. Okay, what is C? C is 10 2. Okay, then draw the polygon. So you'll have to find the new A, new B and new C. Okay, so what is A? A is 2 comma 5. What is tx and ty? Tx and ty is 2. Okay, so here 2 is x and y is 5. So what is the formula for finding x dash? X dash is equals to tx plus x. Okay, so how much is tx? Tx is 2 and how much is tx is 2 and how much is x? T is 2. Okay, so 2 plus 2 is equals to 4. So x dash is 4. What is the formula to find y dash? Y dash is equals to ty plus y. Okay, so what is ty? Ty is 2 and what is y? Y is 5. So 2 plus 5 is equals to 7. So y dash is 7. X dash is 4, y dash is 7. So the new coordinates of A is, I'll name this as A dash. The new coordinates of A is 4 comma 7. Okay, now you have to find out the new coordinates of B. Okay, so what was B? B was 7 comma 10. Okay, this is a new x, this is a new y. What is x dash? X dash is tx plus ty. Tx we know it is 2. Okay, how much is x here? It is 7. So x dash is equals to 2 plus 7, which is 9. And what is y dash? Y dash is equals to ty plus ty. How much is ty? Ty is already there, 2. So 2. How much is y? It is 10. So 2 plus 10 is equals to 12. So what is b dash? B dash is 9 comma 12. So the old coordinate position was 7 10. The new coordinate position is 9 12. Now which one is left? C. Now what is C? C is 10 comma 2. you have to find out x dash, y dash. Okay, x dash is tx plus x. X dash is equals to, what is tx? Tx is 2. What is x? It is 10. 10 plus 2 is equals to 12. Okay, and how to find out y dash? Y dash, again the same formula, ty plus y. 2 plus 2, you will get 4. C dash is equals to 12 comma 4. So the old coordinates of P were A 2 comma 5, B 7 comma 10, C 10 comma 2. So the new coordinates are A dash 4 comma 7, B dash 9 comma 12, C dash 12 comma 4. Okay, so you have to draw the new polygon. Okay, so the new A is 4 comma 7, 4 7. New B is 9 comma 12, 9 12, and the new C is 12 comma 4, 12 comma 4. So the new polygon is drawn. So it has just moved a bit upper. Okay, now this polygon was bit down, this has moved little bit upper. That's it, only the coordinate positions have changed. Okay, so this was two-dimensional translation along with an example.